So welcome to this afternoon session. I'm going to kick this off with covering the Amazon cloud. We've got three topics that we're going to discuss this afternoon. We're really going to talk about security in the cloud. We're going to talk about the features and the tools that Amazon provides to allow you to be secure in the cloud environment. We're also going to look at some best practices for building a secure environment in the cloud and preparing for a PCI DSS assessment in the cloud. And then one particular aspect that you have to pay careful attention to in the cloud is incident response. So we're going to cover that as well. Now, this presentation is actually 3 one-hour presentations sort of crammed together in 20 minutes. So this is going to go pretty quickly. So hang on to your hats. So what we're going to talk about today is security, first of all, in Amazon Web Services. And Amazon in EC2 provides a whole range of tools that allows you to access some of their services. There's CloudWatch, CloudTrail, Configuration, Amazon Inspector, Amazon WAF, and then there's additional tools for flow logging and Amazon's Virtual Private Cloud. And we'll touch on the Virtual Private Cloud when we cover some of the best practices as we move through the presentation. These tools can be leveraged for anybody operating in the cloud to allow you to build a secure environment within the EC2 framework. One thing to really bear in mind, which is absolutely critical about this is a shared responsibility model. So within the cloud environment, Amazon is responsible for certain aspects of security, and you building your application in the cloud, you're responsible for other component parts of that security model. Together, combined together, the overall security is provided across the board with the two, Amazon and yourselves, operating within this framework. You utilizing the Amazon tools, Amazon providing some core frameworks. So shared responsibility model. The thing to bear in mind, there's a phrase here that we use for this, is that Amazon AWS is responsible for security of the cloud, and your responsibility is security in the cloud. So if you look at this diagram here, you can see that the shared responsibility model breaks down into these various core components. I'm not going to go into detail in each layer, but you can see from this diagram, there's different responsibilities in each area. So let's look at some of the tools and features that Amazon provide to allow you to be secure. So one of these is CloudTrail. CloudTrail allows you to capture and record API calls that are made on the platform between various components. One of the other tools is CloudWatch. And CloudWatch allows you to log system and resource information while you're operating within the cloud. AWS Config provides support for various different aspects of the cloud environment. So it allows you to configure your systems and do security analysis on them. This is so you can make the statement, am I safe? Am I okay operating with this cloud environment? Have I configured my cloud environment correctly? It allows you to do audit compliance. So it allows you to collect evidence that shows that you're actually operating in a secure environment. It allows you to track and operate change management within the cloud. And it allows you to do troubleshooting, so you can determine what has changed within your cloud environment. It also does discovery as well, so you can actually determine what resources have been impacted or affected by change and what exists within your environment. So it's a very, very powerful tool. So those blue boxes at the bottom there are the 5 different capabilities of this one individual tool, which is really, really good for operating in a secure environment. So let's look at some of the best practices. I told you we were going to go through this pretty fast, so hopefully you're all keeping up with this. Customer best practice is very important to build different virtual private clouds within the EC2 environment that handle different aspects of your security. So you would build, for example, a Gold Master AMI, where possible, leverage build scripts and bootstrapping to actually build your environment. And a different VPC would handle things like logging. You would have different accounts that operate within different environments. Now, your best practices for building a secure environment still apply. You still have to do centralized logging, you still have to do key rotation and key management, all the other aspects. But you're operating in different environments that allow you to build virtual private clouds that each perform a different function to give you overall security. You start from a known good master, and you should also consider in your security operations and dev security ops automatic systems, and not be using things like SSH and RDP access to instances. Also, one other aspect of using the cloud is the best practice of making sure that keys, API keys, are actually owned by individuals. People get keys, things get roles. Now, I can't go into great detail about this at the moment, but that's a best practice to bear in mind when operating in the cloud. If you want to know more information about this, then come along to our stand and I can explain it more. When preparing for an assessment, preparation is the key. There's no magic silver bullet for operating in the Amazon cloud. Amazon itself covers almost all the 12 major areas of PCI DSS. So we're looking at network and perimeter security, servers and system hardening, protection of stored data. The one area that's not covered in here is physical security. So physical security is a given with respect to the way Amazon operates. There are several areas where controls must be changed to address the cloud environment. We're going to discuss these in the next few slides. So let's look at network and perimeter security. One thing you can't say is you can't say we don't run firewalls, the cloud provider does. You're still responsible for the rules built within your network firewalls. Firewalls still exist in this environment. The standard needs to be adapted for AWS security groups, and security groups need to be in place for egress, ingress, and DMZ control. Network segmentation is still important. You need to have methods for logical control of inter-cloud communications and tied to access controls within your environment. Your servers and systems need to be hardened. Amazon provides tools to do this in their config manager, but they're not going to do it for you. You have to prepare a standard. You have to have standards for approach of system hardening the servers with administrative controls and accounts, and use the AWS tools to know what configuration you're running and test that configuration. You shouldn't really cut corners at all with this in terms of extension of the offices and thinking of the cloud as just another part of your environment. It's a completely separate environment and must be completely isolated and segmented from your operational controls within your own organization. Standards need to be adapted to a clear approach for system and component hardening that you're performing. You need hardened admin accounts. Don't use defaults. So the same process you'll be using for your for any other system applies here. You've got to change the defaults and use the AWS tools as well as scanning tools to test and validate the hardening you're putting in place. Protection of stored data. Retention of data is still your responsibility. AWS cloud services can be leveraged this. Approach for data removal may be different within the cloud because you've got to make sure the data is actually really removed. You may have to develop different approaches for encryption and key management and key storage. There are significant issues here because AWS doesn't provide native tools to allow you to do key management, so that's still your responsibility to handle it. In terms of transport security, you've got a similar approach here. You may need to construct different approaches to transport security to make sure you are implementing the right type of transport for ingress encryption and certificates and management certificates for people that you connect to, and also for the implementation of TLS within the environment. Application security. Now, the good news is that the AWS environment can be perimeter and environmentally hardened stronger than most environments. The bad news is applications are the most significant threat to cloud-based commerce environments, because they're the area which probably has the most vulnerabilities. Applications on cloud environments account for the most list of zero-day attack vectors. Must focus on development of secure applications at all times. So that's really your, if you like, the Achilles heel in this environment, is making sure your applications are actually well tested, well documented, and make sure that they're not vulnerable. Access controls are also equally important. Proper configuration when setting up the AWS environment is absolutely critical and paramount. You must leverage the AWS two-factor authentication controls, and you must look at leveraging the security groups to filter access into your environment. You should be pen testing this environment at a higher frequency level than is actually required by PCI. You should be looking at least a minimum of 6-month penetration testing into this environment, and potentially doing it on a quarterly, if not monthly, basis. A few final thoughts on this. Logging. Logging is critically important. It's very, very vital that you make sure you centralize your logging controls using the AWS tools, preferably to a completely separate VPC. Isolate access to the logs so nobody can actually get into the logs unless they're fully authorized. And review the logs daily, which of course is a PCI requirement. It is critical in this environment that you react appropriately to any intrusion and issues. Wireless scanning may not apply, it depends on the environment, but scanning, testing, and penetration controls are pretty much the same, if not to be done more frequently. File integrity monitoring is also a major topic in this area. The bad guys out there like to modify your applications, they like to enhance your applications with additional features, and FIM should be run daily on your production environment, and certainly the public-facing environments. Tune your FIM servers to watch for malicious software attacks. That's absolutely critical. And the bad guys like to put changes in the images folder, as we'll see in a minute. I'm going to move on to that. So let's look at some incident response planning. Because when you're in this environment, the good news is that it's a highly leveraged environment, highly expandable, and can be easily adapted to all sorts of applications. The bad news is that the hackers and attackers also know that as well. So incident response in the Amazon cloud becomes absolutely critical. So this is actually an extract from a W10 file, and what is it actually showing us? Well, the full story here, and this is from a real incident, is that there were 15,000 unsuccessful SSH login attempts, each exactly 66 seconds apart. And humans don't do login attempts exactly 6 seconds apart. So it's an automated process. We also saw in the W10 last output, when we looked at this, that there were, when the unsuccessful login attempts stopped, there were real logins to the user environment. Those were logged in the logs, but they were masked by all this massive automated logging process that was going on. And what was happening in the background was that they logged in and they modified a PHP script to download information and download a file into the images folder, which was then used to exfiltrate card data out of this environment in real time. So that every time a user hit the buy button, their credit card would be picked up, turned into an image, and sent outside the environment. wget commands are used to download this kind of operational malware quite often. And it's common to have that malware end up in the images folder. And the reason for that is images folders are common on all systems. They change all the time. Changes to the images folders are usually ignored by most system admins because they're just images, and no one tests a file with a .jpeg extension to see if it's really an image. Users using a remote browser to directly call or browse the file in images, so you're not going to have a situation where somebody's going to be scanning and testing these images files to see that they really are an image and there's not something else in it. So unfortunately, in this particular case, a web shell was actually downloaded, and this was used to exfiltrate card data. It actually turned out to be also a modified PHP script was used, and the card data was then successfully exfiltrated. Here's another example here. This is a denial of service attack. In this particular circumstance, it's a DDoS attack on this environment. Because Amazon is such an extensible service, these attacks are actually quite common in the Amazon environment. People know that because it's massively scalable, they're going to be able to use the power of Amazon to attack your environment. And in fact, the attackers may actually be using another VPC within Amazon to attack your VPC. To address the problem here, your incident response plan must be adjusted to activate the correct response. So the classic definition of an incident response in this environment is basically, when you have a violation of policy or law, an acceptable act, you're going to take some action. That's not going to really work in the Amazon environment. You have to be a little bit quicker to actually get through this environment and understand what's going on in a faster response time. Otherwise, you'll fail to respond correctly to any potential attack. So you have to have the following as your planning objectives within the incident response process. You have to have rapid detection of an incident. This is one of the weakest areas for most corporations and organizations. They don't respond fast enough to an incident, and in this particular environment, you have to have a very, very rapid response. We've had incidents that we've actually dealt with where the bad actors have been in the environment, not just for days or months, but for years. And that's no good in the Amazon environment. You can't do that. Understanding the threat, you've got to understand the nature of the threat and analyze it correctly and as quickly as possible within this environment. You've also got to minimize the loss and destruction. You've got to consider the variables that affect evidentiary value. Select appropriate initial response actions for the particular situation you find yourself under. Initial short-term mitigation. So you have to collect evidence. So part of the problem with Amazon, unfortunately, is that unlike an environment that's not in the cloud, evidence that you gather has to be gathered while the incident is going on. You have to make sure you have enough triage process in place that doesn't destroy the evidence or modify the evidence as you're actually trying to collect what's going on in the environment. So that's incredibly critical. So you have to capture volatile data and perform live and triage forensics within the environment while the attack is going on. This modifies your incident response. You can't, for example, decide as part of your incident response to shut down the environment. If you shut down the environment, you're actually going to destroy the very evidence you need to determine what actually happened. And one of the usual things we find when people are in this environment is that they shut down the evidence and then they restart instances back up again with exactly the same vulnerabilities that they had to start off with. And therefore, the attacker just comes straight back into their system and attacks them again. So your incident response plan has got to change. You can't have a turn it off and we'll look at it later type of approach. It doesn't work in the Amazon environment. So the first responders have got to know how to react to an incident. Because it's a dynamic environment, it's a good and bad thing, properly leveraged, it's great. But building the right kind of environment, the right kind of approach to this is absolutely incredibly important. A knee-jerk response, a panic management that says, hey, we have to get this solved straight away, isn't going to work. We've actually seen a case where the attacker forced a company to just reinstall the actual malware back onto the system in one of these sort of panic knee-jerk reactions. So first responders impact is very, very important, and that has to be built into your plan. The Amazon EC2 environment is one of the richest and most robust cloud environments you can work in. Unfortunately, it's got two major weaknesses that you also have to address when dealing with incident response and overall building of your system. It's people and applications. People have weaknesses, they do bad things. That's people within your organization as well as outside. And applications have vulnerabilities. So you must establish a detailed plan to deal with those two instances. So, in closing, when planning for an incident, have a clear and well-documented plan, the details and steps for first response. Do not leave your head in the sand. Don't think the security is just Amazon's responsibility and not yours. And for more information, PSC actually has a white paper, so come along to our stand in the vendor showcase, and we can discuss in more detail exactly how we should be doing incident response within the EC2 environment. And thank you very much for listening to my hurried presentation. So I have to get through it fairly quickly. I'm going to hand back over to Mara.